SpaceX has just completed a test firing of its Super Heavy rocket that lasted for approximately 12 seconds, making it the longest duration firing of the massive booster. The test, which ignited 11 of the 33 Raptor rocket engines, came as SpaceX continues working towards the orbital launch attempt of this Super Heavy first stage and its Starship upper stage. Because the company is developing the Starship vehicle and its Super Heavy first stage using the iterative design and development approach, the test plans are fluid, similar to the rocket's cryogenic propellants. So what's new? Let's talk about all that happened during that short 12-second static fire test. Before the Super Heavy rocket and Starship upper stage can be flown from SpaceX's Starbase facility in South Texas, the company still needs to perform a couple of crucial tests. It is expected that SpaceX will perform at least one test firing of all 33 Raptor engines simultaneously to gain confidence in the entire length of the complex plumbing required to fuel and pressurize the rocket's propulsion system. This test firing is expected to last for a short time. After that, the upper stage of the Starship will be placed on top of the Super Heavy, and the two vehicles will have to go through a wet dress rehearsal together. Recent tests, including the one that has just been concluded, have come to a satisfactory completion without any visible failures, which indicates that SpaceX is maturing in its approach to dealing with the Starship architecture. Following the conclusion of all of SpaceX's technical preparations, the company must acquire a launch license from the Federal Aviation Administration, FAA, a process that is currently underway but has not yet been finished. There is still a theoretical chance that Starship may attempt its orbital launch in December, but the chances of that test flight will be delayed until the beginning of 2023 are growing by the day. This likely happens when companies decide to become too complex and large. Instead of using a single massive rocket, SpaceX could have gone with 4 smaller ones instead. If the launch of Super Heavy were unsuccessful, SpaceX would lose all 33 Raptor engines simultaneously due to its crash landing. In addition, if Super Heavy were to fail early in the flight, then Starship would have an uncontrolled landing. SpaceX would lose the fully stacked Starship, and the total value of what would be destroyed would be over $10 million, coupled with the cost of propellant that was filled in the Starship tanks to get it fired up. SpaceX should have developed and used 4 boosters similar to Falcon 9, maybe with 12 Raptor engines each, which should have been more accessible to produce, design, and maintain. But the question, would such scenario give us the total thrust needed to lift payload? Absolutely not. There is no need for the Starship to refuel or risk another launch because the 4 boosters can lift the Starship into orbit without using any of its fuel. Even if one of the boosters failed while the Starship was in flight, the remaining 36 Raptor engines would still be able to lift the Starship into orbit and bring it back down again. Instead of a vast tower of rockets stacked on each other, that would be difficult to stabilize and control, and all 4 boosters were linked to the Starship from different corners. So now, what will be the path to a successful launch of the Starship? Analyzing each of the several testing stages. That means if any stage of the testing fails, SpaceX will have to take the part to the factory, repair and rectify faults to ensure that every part and component works fine before returning it to the launch pad again. So, at each stage of the test, Elon Musk will be praying nothing goes wrong or explodes, because if that is the case, thousands, if not millions of dollars will be flushed down the drain, and that means another budget for replacement parts. SpaceX activated all 14 of its Raptor engines on this launch for a brief time. Therefore, the recent tests has yet to establish a new record for the number of evaluated engines. Despite this, the lengthy fire duration indicates the longest period of time that a large number of Raptor engines have been fired simultaneously. So where do we go from here? There needs to be more clarity regarding SpaceX's Starship launch system potential route to orbit. Elon Musk, the founder of SpaceX, had stated in the past that the next step would be to test the autogenous pressurization by firing a subset of Super Heavy engines for approximately 20 seconds, and not just 12 seconds. If you may ask why the time is very short, well, we're dealing with materials here and it isn't friendly with high destructive heat. So, testing in a short space of time will have us see progress of what has been manufactured. how it works, and without getting anything damaged or incurring costs. In its cumbersome first stage, the Starship vehicle is being designed and developed by a company using an iterative method to create and develop. Therefore, its test plans are malleable, much like the cryogenic propellant used in rockets. Elon Musk also acknowledged that he would not perform laboratory launch tests using all 33 engines simultaneously in the future. At least according to the SpaceX website, SpaceX will temporarily fill one of its liquid oxygen or orbital methane tanks with nitrogen to fill Booster 7 with approximately 3,500 tons of nitrogen. This nitrogen weighs roughly the same as 3,400 tons of propellant designed to lift extremely heavy loads. If all goes according to plan, SpaceX will most likely perform more than one wetsuit workout before finally loading Booster 7 with around 2,900 tons of cryogenic oxygen and 500 tons of cryogenic methane. Even though the Raptor engine is more reliable than the previous SpaceX engines, this test will be conducted on a considerably larger scale than previous SpaceX tests. The 33 Raptor 2 engine will likely burn approximately 25 tons or roughly 55,000 pounds of fuel per second. This engine is 50% more powerful than the massive Saturn lunar rocket that produced 7 times more thrust than a Falcon 9. However, it requires a significant amount of energy and fuel. It is expected that SpaceX will perform at least a test firing of all 33 Raptor engines simultaneously for a relatively short time to gain confidence in the entirety of the intricate plumbing required to fuel and pressurize the rocket's propulsion system. Also, it's expected that SpaceX will observe how the launch pad will react to the test. Following the conclusion of all of SpaceX's technical preparations, the company must acquire a launch license from the Federal Aviation Administration, FAA, a process that is currently underway but has not yet been finished. There's still a theoretical chance that Starship may attempt its orbital launch in December, but the chances that the test flight will be delayed until the beginning of 2023 are growing by the day. Over 200 countries and thousands of newspapers are reporting on the start of the Starship, which is quickly becoming the focus of everyone's attention around the world. Musk is also enthusiastic about the Super Heavy Booster 9, which has undergone numerous design modifications and will feature a thrust section that will fully isolate all 33 Raptors from one another. This is an essential feature as it will ensure that the failure of one engine will not immediately damage the remaining engines. The static fire of a launch vehicle for 13 seconds over a concrete pad containing water will inevitably cause problems. When exposed to high-pressure flames for that length of time, the water in the concrete will boil, resulting in the formation of steam. When heated to 212 degrees, water will expand to 1,300 times its original volume. At 1,000 degrees Fahrenheit, it swells to 4,200 times its volume. The water boils, turning into steam, exploding from within the concrete, a process known as sprawling. The sprawling process causes chunks of concrete to be expelled at tremendous rates. Fresh concrete has the maximum percentage of water content during the curing process. The test stands can never be error-free as long as the water isn't baked out and the concrete isn't made dense. The conditions of each flight are unique. The amount of time spent exposed before takeoff is significantly cut down. Considering Starship's anticipated travel speed, hardening the platform in preparation for launch will be challenging. Starbase is neither McGregor nor Stannis, and its architecture is not particularly well suited to the conditions under which a super heavy booster would be evaluated. SpaceX might be better off installing a booster test stand at Massey's with a pit of water underneath that is approximately 30 feet deep. For these reasons, SpaceX could conduct tests without risking damage to their launch facilities, and there would be fewer road closures on highways to aggravate drivers and other members of the public. Do you think it's taking too long for SpaceX to lift the Starship from Earth to space? And also, do you think 2023 is a dream year for the Starship to experience its first orbital flight? We can be optimistic because the SpaceX Starship 120-meter rocket is finally fully stacked, and they've tested the 33 engines for launch. Click on the video to know more.